Let r of t be the vector function cosine of t squared I plus sine of t squared j plus t squared k. T is bigger than or equal to 0. We're asked to find the curvature, the unit tangent vector, and the principal unit normal vector. What I want you to do first, though, is to write down a list of things we're going to have to compute to find these things. Try to put them in an order that makes sense, too. So go on, pause the video, and see if you can write down the things we're going to need to know. Okay, so first off, we're going to need to calculate velocity, because we need to know that vector and its magnitude speed to be able to calculate big T. Well, that'll at least get me part of what I need. To calculate curvature, I need to know speed and dt and its magnitude. After I have the magnitude of dt and speed, I can calculate curvature. And then after that, I can take the quotient of these two objects and find the principal unit normal vector. So that's what I'm going to have to do. I'm going to have to make all of those calculations. So let's just back up and start with the velocity. I need to take a derivative as I move from left to right across that vector function. All right, so thinking about the chain rule. And I've changed notation here on the vectors just for convenience, or what I thought was convenient at the time. And the derivative of t squared is 2t. So I found velocity, and now my job to find speed. All right, so I got a 4t squared sine squared of t squared. And I have a 4t squared cosine of t squared. So let's go on and think about factoring that 4t squared out front. Because as happens sometimes, some nice things happen when I have a cosine squared and a sine squared. And I have a plus 4t squared here. My Pythagorean identity says this is 1. So what I really have is 8t squared under a square root, which is 2 root 2t. Now, if that t squared, that 8t squared wasn't, if I wasn't guaranteed that t was bigger than 0, I'd need an absolute value here because I'd have the square root of t squared, right? Which, if t can be a negative value, I'd have to protect with an absolute value. Here I get away from that, or I get out of having to do that because I know that t is bigger than or equal to 0. All right, well, I can knock one of the things off our list. I can compute big T, because that's the direction of motion vector, right? Divide the velocity by its own magnitude. All right, well, looking at that, the t's are going to cancel, the 2's going to cancel, and I get minus 1 over root 2 sine of t squared. Same thing here, 1 over root 2 cosine of t squared, comma, the t's cancel, the 2's cancel, I get 1 over root 2. There's my unit tangent vector. It is a unit vector. You can actually check it to make sure it has a length of 1. Sometimes that is a good idea to check for a small mistake. Wouldn't blame you if you paused the video here to check that. But I'm going to go on and calculate dt so that I can move on and find both the curvature and the principal unit normal vector. All right, so I have big T. I'm going to write that down at the top of the board here. So I'm hoping to have all three of my final answers together here on this board. All right, let's take a derivative. So again, I have to think about the chain rule, and now I have to think about that constant out front. So the derivative of sine would be cosine. So I'm going to have that minus 1 over root 2 cosine of t squared, but now times a 2t. All right, and the 2 over root 2 is going to simplify to just be root 2 here in a minute, but let's go on and take my other derivatives. I already got my chain rule. The derivative of cosine is a minus sign, and then the z component, I get a 0. All right, so let's see what happens here. I get minus root 2 cosine of t squared and t. And then minus root 2t sine of t squared. And comma 0. Now I need to know that vector's magnitude. And from there, I'll be able to calculate both curvature and big N. All right, so again, I see what's going to happen with my Pythagorean identities, right? I'm going to get the same thing out front of a cosine squared and a sine squared. So if I factor that out, I'll have a 2t squared times cosine squared plus sine squared is 1 plus 0 squared. So I end up with the square root of 2t squared, which would just be root 2t. And again, a lot of the times when I do this, I have to think about the absolute value around the t, but I was told at the very beginning that t was bigger than or equal to 0. So I'm ready to calculate big N, or kappa. I'm going to go on and find big N, though. And I just take this vector and divide it by its own length. So looking at this, the root 2t's are going to cancel. And I'm given minus cosine of t squared, comma minus sine of t squared, comma 0. And now I just need to calculate curvature. And I just barely have enough room to think about curvature here. But kappa is supposed to be 1 over speed, which I don't have on this board, but if I go back to it, speed was 2 root 2 over t. So 1 over 2 root 2t. Okay, and then times dt, which is root 2t. Well, the root 2t's cancel, and the curvature everywhere is 1/2. Curvature does not have to be a constant. In this function, apparently the curvature everywhere we look looks the same. It's always 1/2. If you grab this position function, we have a helix. And if you think about the way a helix turns, it's always turning the same way. Big T points in the direction of motion, big N points inwards to the turn. The curvature describes how fast I'm turning at every moment in time.